Hello everyone. I'm gonna present the work called Robust Stochastic Multi-Arm Bandit with historical data done in collaboration with Sarah Bufilja from Amazon. And so the idea is like you have multi-arm bandit. The goal is to find the best arm to select, and the goal is instead of being a human, the question is what happens if we have an AI who's doing that. And material bandit is applied in different environment, clinical trial, ad placement, and stock investment, so on and so forth. And the usual approach to do it is based on UCB or upper confidence bound, that trade between exploration and exploitation, where you have exploitation, which is based on expected reward, and exploration based on upper confidence bound. So there is like a contextual bandit version where the idea is when you observe a context, you decide which arm to play, and the idea is at each iteration you observe those features and decide the arm you play, getting feedback, and you update your value. The most useful approach to do that is based on LinUCB that has two parts, which is the computing the expected reward based on linear regression and computing the uncertainty based on variance. And in our setting, this what I'm presenting here, the question is what happens if you have like corrupted or unbalanced data in your historical information. So for instance, let's say you're chatting with chatbot, and chatbot has like some corrupted information about you or unbalanced data related to your interest. So in order to so basically the problem setting is there is with some probability there is some corrupted context or unbalanced data that happened in this historical data that the agent is observing in order to make decision. So in order to handle that, we have proposed something called historical LinUCB with offline balancing, where we are showing that this algorithm is doing better than the existing state of the art, and showing that the algorithm is following square root T regret, and showing that HLinUCBC is doing better than the baseline, which is HLinUCB and LinUCB in terms of cumulative regret. Similarly, to handle corruption, we based our approach on some robust optimization, counterbalancing the corruption, and also show that our algorithm following square root regret, and shows that the LinUCB, the robust HLinUCBC is doing better than the two baseline in terms of cumulative regret. In conclusion, we introduced an extension of contextual bandit problem. It's related by several real-world applications, and propose an algorithm to handle this problem setting and observe a clear advantage of this proposed approach over the standard contextual bandit. Thank you very much.